Okay, 2 minutes on reciprocal restrictions. Um, Reciprocal is an interesting name. We've been using it, kind of flip it, the reciprocal, but reciprocal restrictions. So we already covered these in rationals, however long ago, where the method is denominator can't equal 0. So let's take an equation like 1 over x minus 2. Well, the method in English in the notes is set the denominator equal to 0 and solve. So x minus 2 equals 0. Add 2 to both sides, x equals 2. Circle your answer. So that's a restriction. That's a non-permissible value. And you may say equals, but they may say what can't x equal? And you might say x can't equal 2. And just make sure your teacher's not a stickler for it. Sometimes you might get your head starting to wrap around like a double negative, because it's like, well, it can't equal a non-permissible, just either stated as is or equals or can't equal. It will matter in many other cases, but either way, be careful with that. And then in the example directly below in the notes that you are hopefully printing out and looking at, well, if we just have something on the bottom that's in factored form, or we have to factor it or whatever, we do exactly the same method. Set the denominator equal to 0 and solve. Or set them both. Or however many of them are there necessary to set. And we threw in all sorts of little idiosyncrasies in the rationals, non-permissibles section. So again, go back there. This is just a reminder. Go to rationals, check out the restrictions, and then come back and we will graph linear and quadratic reciprocals.